Here we're told water's at a temperature and pressure of 30 degrees C and 0.042470 bar absolute respectively. And we're told that if the specific volume of the water is 10 cubic meters per kilogram, determine the quality of the water in this state. So since we're asked to determine the quality of the water, that means that we're going to be in the saturated liquid vapor mixture state. So what I'm going to do is I'm going to go to the saturated liquid vapor mixture table for water, and I'm going to use the table organized according to temperature just because that's a nice round temperature at 30 degrees C, and see what the specific volume is for the saturated liquid phase and the saturated vapor phase, and then compare that to the 10 cubic meters per kilogram. So let's go to that table. So we're looking for the saturated liquid volume table for water, or organized based on temperature. Here we are. So saturated liquid volume table for water based on temperature. And we're working with 30 degrees Celsius. That's right here. The pressure we were told was 0.042470, which is exactly the pressure that's given here. So we know we are in fact in the saturated liquid vapor mixture phase. The specific volume for the saturated liquid is this value, the 0.001 with some other numbers there. And the saturated vapor specific volume is going to be the value right here, the 32.878. So we were given that the specific volume was 10 cubic meters per kilogram. So we know that we're somewhere between those two values, right? We're between this value and that value. So that again reinforces the idea that we're under the vapor dome in the saturated liquid vapor mixture state. So let's remember these two numbers for the specific volumes, and then we'll use those along with the given specific volume to find the quality. So let's go back to the original problem statement. So just a reminder that the specific volume for the saturated liquid state is 0.0010044 cubic meters per kilogram. And the specific volume for the saturated vapor state was 32.878 cubic meters per kilogram. Again, those come from the table at 30 degrees in that saturation pressure. So this actual specific volume we're given, let me write that here, is 10 cubic meters per kilogram. So to find this quality, what we're going to do is just use this relation where the specific volume is 1 minus the quality times the specific volume for the saturated liquid plus the quality times the specific volume for the saturated vapor. Right? Because remember, the quality is the mass fraction that's vapor. So this is kind of like weighted. This formula just is really a weighting of the properties of the saturated liquid and the saturated vapor, and it's weighting those properties based on how much mass there is of vapor versus how much mass there is of liquid. Okay, so we're given that expression. We can rearrange that to solve for the quality. So if you do the rearranging, I'll just kind of give you the final result here. It'll look like this. So if you rearrange that equation, you'll get that, and we know all the values in this, right? All those values are given right here. So we can then solve for the quality, and what you get is the quality is about 30%, 0.304. So that's about a 30% quality. It means about 30% of the mass of the water at this temperature and pressure is in a vapor state, and then 70% is in a liquid state. Okay, so let's go ahead and sketch out where we are on a PV diagram and a TV diagram. Let's do a PV plot first. Here's our vapor dome. Let's draw in an isotherm corresponding to our 30 degrees. So this is a temperature of 30 degrees Celsius. And then we said that we're at a saturated liquid vapor state, so that pressure up there is our corresponding saturation pressure. And this specific volume right there would be our specific volume for the saturated liquid. This would be the specific volume for the saturated vapor. And our specific volume is somewhere in the middle here. So So here we're under the vapor dome, and our specific volumes between those two. And this is just a sketch, so I'm just kind of showing roughly where we are. So that's what it looks like on a PV diagram. Let's do it on a TV diagram, just to be complete. Here's our vapor dome. Here is our isobar. So this pressure, so this is the temperature of the 30 degrees Celsius. And this isobar is the 0.042470 bar pressure. It's the saturation pressure corresponding to 30 degrees Celsius. Again, here's our saturated liquid specific volume. Here's our saturated vapor specific volume. And we're somewhere in between there. Okay, we'll end the example there.